Hello everyone. Today we'll be looking at some quick solutions of All India Akash Test Series JEE Main 2019 Test 2 Code ENF. So let's start with the first question. Question number 31. Which of the following statements is incorrect? So looking at the options, the first option, BeF2 readily coordinates with two additional F- ions forming BeF4 2- complex. Students, this statement is correct. Beryllium fluoride is an electron deficient species. So it has an incomplete octet and it will accept electrons from two fluoride ions to form the complex BeF4 2-. Let us look at the second option. 1 mole of borax reacts with 4 moles of HCl in aqueous solutions. Students, looking at this option, we have borax, which is B4O5 OH4 2-. When it is put in water, it gives us 2 moles of H3BO3 and it gives us 2 moles of BOH whole 4 minus. So students, we can see that it is a diacidic base. It produces 2 moles of base and it is going to react with 2 moles of HCl and not 4 moles as mentioned in the question. So this statement is incorrect. Let us look at the third option. HCOH liberates carbon monoxide upon heating with concentrated sulfuric acid. Students, this statement is correct. So concentrated sulfuric acid is a good dehydrating agent and it is going to take out water molecule from HCOH and all that will be left behind is CO. So HCOH on reaction with H2SO4, it gives us CO plus H2O. Let us look at the fourth option now. CO, NO and N2O are all neutral gases. Students, this statement is also correct. So we have to mark the incorrect statement for this question. So the correct answer for question number 31 is option 2. Let us look at the next question. Question number 32. Consider the following carbides. So we have been given 4 carbides and we have to select the correct statement about the carbides when they react with water. So the examiner is interested in knowing about the type of gases which is liberated. So let us look at the first option, Al4C3. Students, we can see that in Al4C3, the total cationic charge is plus 12. So which means that the charge on 3 carbon atoms should be equal to minus 12, which means that each carbon is in a state of minus 4. So when reacted with water, it is going to liberate CH4. So this will liberate CH4. Let us look at the second option now, Mg2C3. Mg2C3 has a total cationic charge of plus 4. So the total anionic charge should be equal to minus 4. So the species which we have in this compound is C3 4 negative. So which on hydrolysis will give us propyne. Okay. Let us look at the third option, B4C. It is obvious to us that each carbon atom is in a state of 4 negative. So this is also going to liberate methane when it is reacted with water. Now looking at the last option, La4C3. Students, we know that La has a oxidation state of plus 3. So again, the total cationic charge is plus 12, which means that the total anionic charge should be equal to minus 12, which means that each carbon is in a state of minus 4. So this is also going to liberate methane upon hydrolysis. So we can see that only the second option produces propyne, whereas options 1, 3 and option 4, they produce methane. So looking at the options, we can see that the correct statement is statement number 4. So we have to mark option 4 as the correct answer to our question. Let us look at the next question. Question number 33. Consider the metallurgical processes for extraction of metal M1 and M2. So in process 1, M1 is heated with iodine in an evacuated vessel and the metal iodide obtained is decomposed on a tungsten filament. So students, we know that this is the Van Arkel method and it is generally employed for titanium, zirconium, etc. Let us look at the second process now. sulfide ore of M2 is partially roasted until a part of it is converted into oxide, and then further the mixture is heated with more sulfide ore in absence of oxygen. Students, this statement is related to the self-reduction. So, self-reduction can be carried out for copper, mercury, lead, etc. Among the following, metals M1 and M2 can be respectively. So we can see that the metal M1 can be zirconium and the metal 2 can be lead, which is given in option number 2. So students, we have to mark option 2 as the correct answer to our question. Let us look at the next question. Question 34. Consider the following statements about P4O10 and select the incorrect one. So we can probably draw the structure of P4O10 first. So we have the structure of P4O10 as so each phosphorus is tetrahedrally bonded to 4 oxygen atoms. Yes, students, this statement is correct. Each phosphorus is sp3 hybridized and it is tetrahedrally bonded to 4 oxygen atoms. Let us look at the second option now. It hydrolyzes in water to form phosphorus acid. Students, this statement is incorrect. Phosphorus here is present in a state of +5, and upon hydrolysis it is going to give us H3PO4, which is phosphoric acid. So this statement is incorrect. Let us look at the third option now. 1 mole of it requires 6 moles of water for complete hydrolysis. Yes, we can see that there are 6 POP bonds. So 6 POP bonds imply that it is going to require 6 moles of water for complete hydrolysis. The third statement is correct. Let us look at the fourth statement now. It is used as a dehydrating agent. Yes, it is used as a dehydrating agent. So students, the incorrect statement among the ones given is statement 2. So we have to mark statement 2 as the correct answer to our question. Looking at the next question now. Question number 35. In which of the following reaction dioxygen is not formed? So in the first reaction, XeF4 plus O2F2. So O2F2 is a fluorinating agent, will have XeF6 plus O2. So dioxygen is formed in this reaction. XeF4 plus H2O. So we have to hydrolyze XeF4. So in the hydrolysis of XeF4, the products formed are Xe plus XeO3 plus HF plus O2. So this is a disproportionation reaction of Xe. So Xe goes from a state of +4 to a state of 0 and a state of +6. Plus the oxygen gas is also liberated. So option 2 also produces dioxygen. Let us look at option 3 now. Fluorine, when reacts with water, it forms HF plus O2. So O2 is also liberated in the third reaction. Let us look at the fourth option, XeF6 plus H2O. So students, we know that the hydrolysis of xenon hexafluoride is not a redox reaction. It is a normal hydrolysis in which xenon plus 6 compounds are formed. We can have oxide, we can have oxyfluorides as well. So this is the correct answer to our question. The oxygen gas is not liberated in this reaction. So the correct answer for question number 35 is option 4. Let us look at the next question.